we're going to learn how to simplify radicals. So the opposite operation to addition is subtraction, right? And vice versa. The opposite operation to multiplication is division. The opposite operation to power is radical. Radical. For example, if I have 2 to power 3, which is going to be equal 8, because 2 times 2 times 2, right? Get 8. Then this power, I can use radical degree 3, because of this 3 here, from 8, it's going to be 2, which means I have to raise 2 to power this 3, 2 raised to power 3 to get this 8. Another example, 3 to power 2 is equal 9, which means since the power is 2, I don't need to put any degree here, like 2. So, and all I'm doing, put here 9, and I'm thinking, what number squared will give me 9? It's going to be 3. And one more example, 2 to power 4 is equal 16. So 4 times 2 times 2 times 2 times 2. This is how easy I'm doing. 2 times 2 is 4, 2 times 2 is 4, and 4 times 4 is 16. Which means if I want to write down opposite operation, I'm going to write down radical. This 4 comes here, and here is 16. And we know that 2 to power 4, it gives us 16. Okay, so let's practice, see how we are going to simplify radicals. And first of all, we are using the most common one, which is square root. Square root of 20. So there is no number that you square, it's going to give you 20, right? But sometimes there are some partial numbers you can take out. How we are going to do? Okay, 20 I can break down as into factors like 2 times 10, right? 1 times 20, 4 times 5. Do you see any number that you know that it has square root? I do see here 4. So I'm breaking down into that factors 4 and 5, which is going to be square root of 4 times square root of 5. Square root of 4, it's going to be 2, and 5 is staying like that. What does that mean? 2 times square root of 5. Next one, square root of 98. Let me clean this so it won't look here messy. All right. Yeah. So square root of 98. Let's see. I'm thinking I can break down 98 as a 49 and 2. Why I'm taking this pair? Because I know that square root of 49 is 7. So I'm breaking down square root of 49 and then times square root of 2. And I'm getting 7 times square root of 2, which is same thing, 7 square root of 2. Okay. 72. 72, well, let's see how many numbers we can break down. We can break down 36 and 2, right? We can break down 8 and 9. What else we can break down? 18 and 4. Okay, well, okay, let's do this 3 for now, let's say enough. So from this pair, 4 can come out, right? Because square root 4 is 2. from this pair. 9, I can use, square root will be free. And from here I have 36, I can use, 6 will come out. Here is a question, which one to take out? I'm looking. If I take out a square root, put square root 4, choose this and this the pair. Then if I take out this 4, I'm going to have underneath 18. Which 18, I still can break down some more, right? 9 and 2. And 9, I can take square root of 3. If I take 9, if I take 8 and 9, then 8, I can break down as a 4 and 2. It takes square root 4 will be 2. So therefore, I'm going to take, here is 2, because this second term, this 2, is a term that nothing will come out. So those will be incomplete. Then I have to break down again 18 in this case. In this case, I have to break down 8 again. But this is the best version because I have the number that I can't take out anything else, which means 36 will take out as much as possible. Therefore, I'm breaking down square root 36 and square root 2. So square root 36 is 6 and square root 2. That will be the answer. Next one, 24. So what we are going to do, 2 and 12. There is no square root of 12. 6 and 4. Okay, if I take square root of 4, from 6, can I take out anything? No, I can't. So which means I am writing down square root 4 times square root 6. And that's going to be square root of 4 is 2. Square root 6, it gets stuck under square root because there is nothing is coming out of 6. Even if you break down 6 with 2 and 3, right? Still nothing come out from 2 or 3. Okay. Next, 100x squared. 100x squared. So, we can break down square root of 100 and then times square root of x squared. So, square root of 100, it's going to be 10 because 10 squared is 100. And square root of x squared is x, right? Or if you represent as a rational the exponent, look, remember, this is your 2. Here is also 2. So you write down 2 over 2. It's going to be 1. So 10x. Okay. Next one. Square root 48, a to power 12, b to power 13. All right, let's see, 48, what numbers, terms I can break down? 6 and 8, 12 and 4, what else it can be? 16 and 3. Which one you think would work the best? Of course 16 and 3, because with 16 we have free number that you can't take anything out. Okay? So if I take 4, let's say here, then 12 I can break down 4 and 3 and take again 4. If I take 6, out of 6 nothing comes out. 8 I can break down 4 and 2 and so forth. So 16 is the best. We are going to do square root 16 times square root of 3 and then square root a to 12, and I can write down b to 13. Okay, let's see, square root of 16 is 4. Square root 3, it's going to stay the same. I'm writing here because I'm going to take out this a and b. So a to power 12. Remember what we do? We take this 12 and we divide by these 2, right? 12 divided by 2 is going to be 6. So a to power 6 comes out. Now b13 divided by 2. What do we get? 13 divided by 2, it's going to be 6 and 1 remainder, yes? So b to power 6 comes out. Remainder going to stay underneath because doesn't have enough. That's all. Okay? Let me put another one here. Example, square root a to power 15. Okay, since we don't put anything, that means degree is 2 here, right? So 15 divided by 2, how much is going to be? 7. Remainder is 1. So a to power 7 comes out. This 1 stays underneath because we need 2 to come out, right? Because here is 2. So we have to have here 2 since it's 1, so it's not coming out. Another one. I'm going to drill into this a little bit so you can feel better. So a to power, let me see, 13. No, okay, 17. A to power 17. And here I put cube. So 17 divided by 3. It's going to be 5 times, right? 17 divided by 3, 5 times. And remainder is 2. So what I put in here, this is cube, and a to power 2. So we need to have here 3, so to take 1a out. Okay? Okay, one more. Square root. Okay, let me see. Do I want square root? Let me put 4 here. And I will put here k to power 22. Okay, 22 divided by 4. It's going to be 5 times, right? K to power 5. And 22, oops, I put 50. 5 times. And from 22, it's going to be remainder 2, right? Therefore, I'm putting here k to power 2. And this is degree 4. Okay, moving on. Next problem. We are going to have 90 okay, x to power 7 y z to power 4. All right. So how can we break 90? 2 and 45 is not going to work. I say 9 and 10. Because 10, nothing comes out, right? You can't even break down. You can only break down 2 and 5 and no square root from there. 9 and 10, I say. So out of 9, square root 3 will come, 3 will come out. 10 gonna stay underneath. And let's see, x over 7. 7 divided by these 2, it's gonna be x to power 3, right? And remainder is, oops, hold on. X to power 3, and remainder is 1, right? So this 1 stays underneath. Y, since we have degree 1, so nothing you can take out of y, it's going to stay underneath. Z to power 4, and its square root, 4 divided by 2 is 2. We get z to power 2. Okay? That's all it is. Next one. Let's do another one. (128) square root 128 x to power 9 y to power 3, and we have z. Okay, 128. I am breaking down at 64 and 2 because square root of 64 is 8. 2 is gonna stay underneath. x to power 9. 9 divided by these 2. This is this 9. Divided by these 2, it's going to be 4, right? X to power 4 and 1 remainder. So this remainder stays underneath. It's degree 1. Z to power 3. Y to power 3 divided by 2. You get how many times? 1 time, right? Or you don't put that 1. And 1 is going to be remainder. So this one is going to stay there. Let me clean this. We don't put 1. Because when we say y, we understand degree 1 and coefficient 1, yes? Okay. And z without any hesitation, we keep it underneath because z has degree 1, but we need 2. All right? There we go. Now let's do addition of radicals. 7 square root 3. Let me see, 7 square root 3 plus square root 3. Okay, to be able to add radicals to each other, we have to have same radical. What do I mean by that? We have here square root 3, we have here square root 3. Which means, when we have same radicals, we can add or subtract or do operation. If I add addition and subtraction, if I have square root 3, my coefficient here is going to be 1, right? So 7 square root 3 plus 1 square root 3, it's going to be 8 square root of 3. Next one. 8 square root of 3 plus 11 square root of 11 and minus 9 square root of 11. Okay, we can add these two terms. Square root 3 is going to be like zombie. There is nothing to combine with the 8 square root 3. Therefore, what's happening? 8 square root of 3 is going to stay as is. Square root 11 minus 9 square root 11. That's 1 minus 9. It's going to be minus 8 square root 11. How we got negative 8? So this is 1 minus 9. And that is going to be 8. Okay? Next one. Number 10. Question number 10. This is 10th problem I'm solving. 3 square root 48 plus square root 75. How we're going to add these two together? First of all, 48, 75, we are trying, going to see if we can partially take out. So 48, I'm breaking down as a 16 and 3. 75, I'm breaking down as a 25 and 3. Look what is interesting, it's coming out here. Both of them end up with square root 3, right? Which means we can add them up. And the 16 square root comes out, 25 square root comes out. Okay, let's see, 3 times, this is this 3. 16 square root of 16 is 4, and square root 3 stays underneath, plus 25 square root 25 is 5, and square root 3 stays underneath. That means we have 12 square root 3 plus 5 square root 3. The result is 17 square root 3. All right? Next one. Negative 5 square root 8 plus 3 square root 2 plus square root 18. Okay. So what can we break down with? 8 is going to go 2 and 4. Here is square root 2. We can't do anything anyway. 18, I'm breaking down 2 and 9. And see what interesting thing is coming out. We are going to end up with square root 2 in everywhere. That is equal negative 5. Square root of 4 is going to be equal to negative 5 times 2 and square root of 2. Okay, plus 3 square root of 2 and then plus square root of 9 is 3 and square root 2 stays there. So what do we get? This is going to be negative 10 square root of 2. So square root of 2, square root of 2, square root of 2. Excellent. We can add to each other. Let's do it. So negative 10 plus 3 is negative 7. Negative 7 plus 3 is negative 4. So negative 4 square root of 2. Okie dokie. Moving to next one. 6 square root 3x plus 5 square root 48x plus 4 square root of 108x. All right. How I'm going to solve this one? So first one, I have 3x, nothing comes out, so 3x is gonna stay underneath. Second one, 48x. Since my first one is 3x, I'm trying to see if I can break down the way so I will have 3x here left over also. If I break down here, I will 3x. What is gonna left there? 16, right? Bingo. Good deal. 16 I can take square root, the 16 I can take 4 out and 3x gonna stay underneath. Let me try to do the same thing here. 108x. If I take 3x, so what I have to multiply 3x to get 108? 10 divided by 3. It's gonna be 3 times. 18 divided by 3, it's gonna be 6 times 36. Okay, we have square root of 36 also. And again, beautiful picture, 3x, and we have there 3x. So what do we get? 6 square root 3x. From the second one, square root 16 will come out 4, and square root 3x will stay underneath. And from the third one, square root 36 is going to be 6, and square root 3x. Beautiful job, huh? We have the square root 3x everywhere. So, which means we can add them up. It's gonna be, oh, I'm sorry, this is plus. I forgot this 5 here. See, this 5 I forgot. So let me add. This is what I'm going to do. There we go. 5 times and plus. And 4, this one also here, this 4 also. Okay. Let me fix all around my mistakes. Plus, and it's going to be 4 times. Okay. Now we have it. So what do we get here? Equal 6 square root 3x plus 20 square root of 3x plus 24 square root of 3x. Okay, what do we get? 6 and 20, it's going to be 26. 26 and 24 is going to be 50. Why we can add? Because everywhere we have same term underneath. So we said it's going to be 50, right? 50 square root 3x. And that is our answer. Next one. Square root 275 minus square root 8x and plus square root 18x. All right. Well, let's pay attention on something here. 275 doesn't have x under square root while the other two have it. What does that mean? That means that right away that 275 we will not be able to combine with these two terms. Well, we're assuming that 8x and 18x will have under square root same term, but this one, 275, we can say up front, we won't be able to combine because there is no x in there. All right. So 275, how can I break down? Let me see. 275 I can break down as 11 and 5. I mean 25. 25. How about 8x? 8 I can break down into 4 and 2. And let me guess, this x I'm attaching to 2 because x cannot come out. It's only degree 1, while we need 2, right? And 2 is going to stay underneath anyway, so we will put 2x. 18, so let me see if I can get 2x out of here. Yes, 9. Perfect. So we are going to get from the first term, square root of 25, it's going to be 5, and underneath it's going to stay 11. And then square root of 4, and we are going to get 2, and underneath going to stay 2x, plus square root of 9, it's going to be 3, underneath will be 2x. So these two ones are like terms, and the answer is going to be 5 square root 11, and these two, it's going to be 2 plus 3 is 5 square root 2x. Oh, hold on. We have here subtraction. 1 second. So I'm going to change this. Put subtraction minus. Okay, if I subtract, then negative 2. Negative 2, positive 3, it's going to be positive 1. Okay. So I'm taking away this, and I'm getting plus square root of 2x. All right, let me do one more. Let me separate a little bit, bring more down, so it will be distance between those, so for readability. And the last one, let me solve square root 12x squared minus x cubed, rather. Let's take x cubed, make it more fun. And minus x times square root 75x. I know up front that 75x I can break down 25 and 3x. Therefore, I'm looking, this 3x going to stay underneath. If I break down here 3x, here it's going to be 4x squared. Bingo. Okay. See how I'm figuring out? Because 75, I already know it's clear. 3 and 25, and x going to stay with the prime number. So here also I separated prime number, 3x, same 3x, and got out 4x squared. And nicely, square root of 4x squared, it's going to be 2x underneath 3x plus minus. We keep moving to plus, I don't know why. Well, positive things, who doesn't like it? Who likes negative things? Okay, square root of 25 is 5, and the x we have also, it's going to be 5x. And the square root of 3x stays underneath. Okay, we have like term 2x minus 3x. I mean minus 5x with square root 3x underneath. It's going to be negative 3x square root 3x. All right, I hope this will help. And I'll see you next video.